Yeah, hi Mac.
Yeah, yeah. I think we can in real life, kind of, if you have bookshelf,
Perfect.
yeah, and
That's what I was looking for. So whenever you're reading a book, let's say you are in 10th standard, 8th standard, 11th standard, there
yeah,
is a index in front of a book, right? In
yeah,
the starting of the book itself, where you can refer like which chapter is at which page number.
yeah,
Correct? So the way indexes work is in the similar fashion. It tells you where you need to go in order to find something. I mean, you don't have to like go through the whole book in order to find where is the 10th chapter. You can go to the index and then look for the 10th chapter, and it will tell you at which page it is, from at which page it starts and at which page it ends. Correct? You don't have to go through the whole book. And what it does is essentially it saves your time. It increases your performance. How it saves your time? Saves your searching time going through the whole book, finding where is the chapter. Okay. And how it increases your performance is, let's say if it was not something you were looking for, then you know now that you don't have to go through the book again. You can just go to the index, find again in the index whatever you're looking for, and you're good. That's how indexes help. That relookup thing is also easier, and searching and sorting thing is also easier. So in the database also we have indexes, functionality of index. And what we can do is we can create an index by using a simple command. So let me first define what is an index. So as we were talking about, indexes are a special lookup table that the database search engine can use to speed up data retrieval. An index helps speed up select queries and where clauses, but it slows down data input with update and insert statement. Indexes can be created or dropped with no effect on the data. Now, I would like you to lay stress on this particular statement, but it slows down data input with update and insert statement. Can you tell me why would this happen?
we are creating index of all the records.
Okay, but then why it would be slow? I mean, why would it slow down the update and insert operation? Okay, let me give you an example. So think of it that way. You have created a book, Mayank, where you have 10 chapters, right?
Mhm.
Now, I would like you to, I say that, Mayank, can you add an 11th chapter at the end?
Mm.
It's fine, right? You can do that. It's easy. But what if I ask you that, Mayank, I don't like the discontinuity between fourth and sixth, fifth chapter. I would like you to add a chapter in between.
Mhm.
Now, what you need to do? First, you need to tear apart the rest of the chapters, put a new chapter in between, and then
Yeah,
put all the next chapter after that, right? And you need to
right,
check the sequencing also.
right,
Like your fifth chapter will become sixth. There is a new chapter which will be called fifth, and now rest of like the way fifth has become sixth, sixth will become seventh, seventh will become eighth, eighth will become ninth. Correct?
right.
All the things need to be updated. Similarly, in the database also, whenever there is an update or insert statement, if it is at the end, it would be faster. But if it is at in between somewhere, then the index need to be modified, and the whole chain of operation need to happen. Like new insert will go in between, and the rest of the commands will go and update afterwards. Make sense, right?
Mm, yeah, yeah.
No,
Can you repeat again? Last part.
yeah, I'll repeat. So think of it that way. The way we were talking about chapters, right? Let's say
Uh-huh.
in case if we need to insert a record in between a table,
Right.
then we need to do the same operation. Like we need to update rest of the indexes. I
Yeah.
mean, this index for the rest of the records. If we are inserting a record in between, and then the whole operation need to happen. Like a new insert will happen, plus the rest of the records will get updated. Like six will become seven, seven will become eight, eight will become nine, so and so forth. So the more record you have, the more that operation costlier it will become. Okay.
Right, right, right.
Okay. Next. So the simple syntax we have: create index command is as simple as create index. Then you need to give an index name. then there is an on clause, like on which table you would like to create that index, and then you need to provide a column, like on which column you would like to create an index. It is highly suggested that you create an index on primary key, because primary keys are a unique identifier of each record in a table, right? So when you create an index on a primary key, you'll be able to retrieve any record, any column from the table in a faster time. Make sense?
Yeah.
So the way I was telling, there are then the certain indexes are called implicit indexes. In case of primary key constraint and unique key constraint, these are the indexes which are automatically created by the database itself in order to do a fast retrieval. So let's say there is a primary key, you have declared some column as a primary key in your table, then you don't have to explicitly create an index for that primary key. A database behind the scenes create an index, an implicit index on that primary key, and then that particular whenever you are querying something using primary key, the data retrieval operation become faster because of these implicit indexes which are created by the database automatically when you create a, or when you mark a column as a primary key or a unique key. And then you can simply drop an index by using a drop index command, like drop index name on table name. So
What if, let's suppose, we are creating index, but which is not a primary key?
you are creating index, but yeah, it's possible. We can do that.
Okay.
So actually, there are several different types of indexes we have.
Mhm.
So in the next session, we are starting views, right? Let me walk you through. Give me a sec. Best way to show you is SQL Server docs. So this is the latest documentation that we have from Microsoft, and we have different types of index: clustered, non-clustered, unique, column store, index with included column, index on computed columns, filtered, spatial, XML, full text, hash. This one actually I would like you to tell you first. Hash index is the very optimal index, but what happens is here, so it creates a hash table. Hash table is nothing but like a mapping table that uh, you don't have to, whenever a new record will be inserted, it can be at the end at the end of the index also, but it can even point to the in between record as well. So let's say you have 1 to 10, but I would like you to insert a fifth record in between, and it would be there. But instead of in between, it will be added at the end with the hash value, which will be directly pointing to the fifth record. So it saves the time over other indexes in this way. Now, the way hashing work, why do you think, do you know the concept of hashing?
No.
Okay, let me make it simpler for you. What if I tell you that uh, using a hash, you can directly find where that record is. So let's say there are hundreds of rows, okay, and there is, like, not talk about hundred of, let's take millions of rows are there, and they are spread across different databases, let's say different table names and different partitions. Now you have a hash value, which is something like a combination of database name, table name, partition name. So now when you would like to find a record corresponding to that hash value, all you need to do is go to that hash value and it will tell you which database to go to, which table to go to, and which partition to go to. Correct?
Yeah.
You don't have to find anything. That's how hashing works, that it directly takes you to the record and it converts basically the hash value to that record position itself by using certain operation. There are n number of operations that you can use in order to create a hash. But yeah, that's how in a gist hashing works. So it takes a fixed amount of memory, fixed amount of space in order to do all the operations. So it's going to take, even if you would like to fetch the last record or the first record or any record in between, it will take the same amount of time for hashing to navigate it to that particular record. So hash based index is a very good in-memory indexes that we will highly suggest to create hash based index. Another one are memory optimized and non-clustered index. So first we will, I would like to give you an example.
So for these all indexes, we have different operation we have to perform, right? For
Different keywords, yeah, different keyword, different syntaxes, and all you need to do is just mention while creating an index the kind of operation you want to perform.
okay.
Like, I'll show you something like this. With memory optimized on durability, schema, and data, and you will like you would use some keyword like non-clustered here.
Okay. Okay.
For hash, it would be something like this. This is declaration consideration. Yeah, we have hash is there, right? Yeah. We are creating a hash on column 2 with bucket count of 64. So, I mean, these are different different ways, we have different keywords and ways involved to create different types of indexes. But mostly you will come across clustered and non-clustered indexes, and I'll show you the difference. If there would be any drawings, I would like to get those. So let's take this example. So clustered index, there are two conditions that we basically need to satisfy. First, data or file that we are moving into secondary memory should be in sorted order. Next, there should be a key value, meaning it cannot have repeated values. Key has to be a unique value. So this image gives you a right example, like 1, you can refer to this particular record. 2, you can refer to this particular record. So there is a each key for each value in the record set. Whereas non-clustered index is similar to the index of a book that we have. Like it's in a haphazard manner. You can go from anywhere to anywhere. So it will have location of that particular record. So let's say 1 can have location of 1 here, and it's not in sequential order, right? So this is one of the reason. I mean, in case of non-clustered index, your insert and update statement are faster because it's in a haphazard manner and you can insert it anywhere. But your retrieval is not that fast as compared to a clustered index, since it is in an sorted order. Makes sense, right? If
Yeah.
it will be sorted, you need to know like where you need to go, and directly you can jump there.
Okay.
So mostly you will come across clustered and non-clustered, and then the unique indexes. Unique indexes basically create on a column which have a unique constraint, and there are no duplicate values in that particular column. Then there is memory optimized non-clustered, memory optimized clustered. Then there is a column store also. So you can create a column store index on the basis of column which are used most often than the others. So let's say you have a table with hundreds of columns, correct? Now the thing is, you know that out of those 100 columns, only 10 columns are used most often. Other columns are not used that often, right? What you will do is you'll create a column store index on those 10 columns, so that whenever you are querying those 10 columns, your data retrieval will become faster. And there is a filtered index. So filtered index, think of it that way, that you know that there's a million record set, and now you know Like I mostly retrieve data only for India region. And when you filter data for India, it become 100,000 records. So you can create a filtered index on for India region where the records will be retrieved only for India region from that particular table in a faster way, in a faster time speed span of time. Okay. Any doubts still here? Mayank, Pratiksha?
No, no, no. That I think we have to practice this indexes. Then like kind of.
Yeah, no, no. So indexes is generally index as a concept is there in the interview. That's why I'm telling you theoretically,
Okay.
showing you. So I can even show you indexes. I'll show you. So let's say there is exist a primary key, right? There is an index on product ID. Clustered index is there. Correct? Then name also unique non-clustered index is there. Product number unique non-clustered index. Unique non-clustered. So indexes are there. I mean, these are created by the system. This one is created by the system itself, since it is a primary key. So I mean, indexes is a good part of our data. Being a data engineer, it's a good part of your work because you need to optimize the way your database works, the data retrieval works, and you cannot just let it take forever to load the data. If someone has queried something, it should not be like it's taking just a hell of a lot of time to retrieve the data itself.
Yeah.
So optimization is a good portion of it. But from the interview perspective, I can tell you that it's theoretically conceptual only indexes. No one is going to ask you to create an index and optimize a table. That's not going to happen in an interview. So your theoretical concepts, usage of indexes, different types of indexes, which index to be used when should be clear. As long as you're good with it, from interview perspective, you're good. From your day-to-day life, believe me, 90% of the folks who are developing indexes refer to the documentation. Even I refer to the documentation. Reason being, every now and then, these documentations are getting updated, new index policies are coming, and the way they are supposed to be implemented. So we need to keep ourselves updated. So always go through the documentation while creating indexes and browse through the documentation as well. Like what are the different options which you can leverage while creating these indexes. Okay.
Yeah.
Very first question in an interview, if someone asks you, why would you create an index? So what would be your answer?
To optimize basically, right? How we can pull the data.
Perfect. To optimize data retrieval to increase performance.
Yeah.
That is the fundamental need of indexes. Okay.
Yeah.
Awesome. I think session 3 is also done from my end. I'll share this PDF with Abhishek and then I'll ask him to provide you all the 3 PDFs.
Yeah. Yeah.
We have a few minutes. If you have any questions, we can go through those questions now.
I don't have any as of now because I have not practiced this week. Actually, I have to go to office, so I could not did the hands-on. Maybe.
I would like both of you to I would like to encourage both of you to do a hands-on as well.
Yeah.
Because when we are listening something, when I'm doing it, I'm doing everything, it's working fine, right? So you will not face any challenges. But when you will do it on your own, you will start getting into certain challenges like why this is not working, why that is not working. And there I will be able to help you better, because once you run in those challenges now, you get to learn the concept and you're trying to do things on your own. Right now it's like I have told you, you are doing this, it's copy paste and it would work. But when you do something on your own, then when you run into challenges, at that particular point of time you need help, and that I would like you to leverage now since I am here. So tomorrow 4 sessions will be done, 2 weeks are gone.
Yeah.
Another 2 weeks we have only. So I would like you to utilize those 2 weeks to the maximum, and yeah, ask me any doubt that you have. Okay.
Sure. Also, this database link, can you share? Because last time you shared here in the Zoom window, but it caused
Yeah, I did.
disappear. So, if possible, can you share on the WhatsApp so that it will be there whenever?
Uh,
WhatsApp group we have, right? So
I don't think so. We have a WhatsApp group.
okay.
But yeah, I can
Just
change this again here. You can
sure.
just refer to this.
Okay, I will.
Let me know if you're able to see. On this link, you just need to go here, 2019 BAK or LT 2019 BAK.
And then SSM, we have to import this, right?
Yes, in SSMS you need to import. I'll say not import. I'll use a word called restore.
Okay.
So what you need to do is go to the server section, right click on databases, click on restore database, and then this kind of window would open, and then you need to go to device, click here, and then select that BK backup file.
Okay. Okay. Got it.
Select the backup file, click on add, hit OK. You should be fine. Okay.
Got it. Yeah. Thank you.